Lauren.
Hi.
How are you tonight?
I'm good. How are you?
Good. Okay, last time we went through 16. I think we might have even done 19 because I seem to remember skipping 17 and 18 because we didn't have quite enough time.
Yeah.
So let's work on 17. Let me draw the picture to make it a little easier to talk about. Nice if I could draw a straight line, but not in this lifetime.
No, it's not possible.
So the diagonals of that rectangle go through the point 5, comma, minus 1. And in the problem, they tell you that this point is minus 1, minus 4. They want the coordinates of that point right there. First of all, fairly not high degree of difficulty, but at least medium.
Mm-hmm.
So, if you're about to give up on this, look at the answers and see what you could eliminate. What can't possibly be the coordinates of that point?
E?
No, E is one of the few numbers that could be. Could the points, could the coordinates of this be minus 6, comma 2? Look at it. Where is it at?
Oh, no.
Okay. Could it be minus 1, comma 4?
No.
That's what I mean by, if you don't know how to do the problem mathematically, then eyeball it and see if we can come up with a reasonable guess. Well, 9, comma 3, I could believe that we'd go out 9 units and up 3, so that's a believable answer. About 10, comma minus 3.
No.
So C and D are the only two answers. That's pretty good. Even if we're guessing, we're going to be 50-50 right without knowing anything. Now let's review the math of it. What we know is that two diagonals of a rectangle bisect one another. So this is the midpoint between M and O. Let's not call it MP. Let's call it midpoint. So knowing that, what's the x-coordinate of this point going to be? Look at what the x's do going from here to here, and we have to go an equal further distance to there.
What is it like?
How far is it from point M, just the x-coordinate? In other words, how far is it from here to here? What's this distance there?
A -4 or a 4?
No. You have to subtract the two numbers. What's 5 minus a -1?
6.
Okay. So that distance is 6, just talking raw distances. Okay? Now, before we go on, the fact that you had a little bit of trouble with that, let's look at a number line. When I say how far is it between -1 and 5, I don't really care whether it's plus or minus. I'm just looking for a distance. Well, what's the distance between -1 and 5?
6.
Yeah, it's It's 1 there and it's 5 there, 1 plus 5. So if ever you have difficulties adding or subtracting positive and negative numbers, it can be helpful to lay them out on a number line, especially if you're just looking at the distance between them. Notice that 5 minus, in other words, this number minus that number is equal to plus 6, and minus 1 minus 5 is equal to minus 6. So I get the same distance regardless. I'm going to have a different sign depending on which one is first, but in this case, I'm going to the right. So I know I'm increasing my x-coordinate by 6 units. So that's what I have to do from here to here. This distance also has to be 6 for the x-coordinate. Therefore, what's the answer? We don't even need the y-coordinate because it's multiple choice. What's the x-coordinate of this point?
But we just know 6, so do we...
We know that it has to be 6 further than 5, so it has to be 11. In other words, this midpoint bisects the two x-coordinates.
Okay.
If I'm bisecting between minus 1 and 11, halfway between those two is there. It's 6 away from the minus 1 and it's 6 away from the 11. Since the x-coordinate answers the question between C and E, I don't even need to worry about the y-coordinate. But let's talk about the y-coordinate anyway.
Okay.
What's the distance between this y-coordinate and this y-coordinate? In other words, going from minus 4 to minus 1. How far is that?
3 or...
Yes. And so this y-coordinate has to be 3 higher than this y-coordinate.
So 2.
So 2. On a number line, there's minus 1, there's 2, there's 3 units in there. In other words, the difference of these two numbers has an absolute value of 3. And that's all we care about is the absolute value, because we can figure out what the sign is. We know it's not minus 2. Even if this wasn't multiple choice and we had to do this, what we see is that we're going from minus 1 to 5, so we have to keep going to the right. So that's a positive 11. And we're going from minus 1 up to minus 1, so we have to keep going up another 3 units to get the plus 2.
Okay.
All right. So what's the equation that is going to give me the total amount that Tony earns? Tony earns what?
Wouldn't you do like 63 equals, or...
He doesn't get paid the same per mile for every 63 miles he runs.
Oh.
He gets 9 cents per mile for the first 25, and then he gets 7 cents per mile for every mile between 25 and 63.
Oh. So would there be 2 equations?
No, but there's 2 parts to the right side. There's the 9 cents he earns times the 25 miles, plus what?
Plus the 7 cents.
Do you have your calculator handy?
Yeah. 38.
There's your answer. Go ahead and get numbers for that. This is 225. This can't be much different than 225. It's a little bit, a little less and a little more. So it's got to be 491. There's nothing else that could even be close. Without doing any math at all, I knew it had to be 491. First of all, I know that 9 quarters is $2.25 if you had it in your pocket.
Okay.
And notice this number here can't be too different from that. First of all, 7 times 3 is 21. It's less cents, but more miles. So this has to be a number in the vicinity of 2 plus also. Well, if you look at all those answers, there's only one answer on there that's $2.25 plus 2 and change. Not that you need those little tricks as long as you have a calculator, but
I'd be faster.
well, it actually is. And I guess what I'm trying to point out is that they usually put their answers so far apart that is all you have to do is be in the ballpark.
Okay.
And you can guesstimate it. Like I said, not a big advantage because you have a calculator, but let's notice some other things about this problem. 30 days. Did that have anything to do with anything? No, not a thing. And yet it's in there twice. It's up there 30 days and it's down here 30 days. Has nothing to do with anything. Okay, we did 19. So let's look at 20. What makes something undefined?
When the 0 is on top or the bottom, I don't.
Division by 0.
Okay.
You go on the internet and look up, type in the 10 commandments of mathematics. You get 8 different lists, and every single one of them, the first commandment is thou shalt not divide by 0.
Okay.
What happens when you divide by 0? You get infinity, which is the same as undefined. I can divide 2 by 0 and I still get infinity. If I divide any number at all by 0, I get infinity.
Okay.
Okay? So what can't be 0 is this. So now how do I solve that?
Wouldn't you do like
You set it
100?
equal. You set it equal to 0 and solve. And that's going to tell us what x cannot be. In other words, if 100 minus 4x squared is equal to 0, we can figure out what value of x is going to make this denominator equal 0. So now let's solve this.
Do you want me to tell you, or do you want me to tell the answer? Or...
I want you to tell me how you'd solve that.
Okay.
Step by step.
You would add 100 to 0.
No, that's not going to move 100 from, if I added 100 to both sides, I got 200 on the left now, and then 100 on the right.
Or subtract it.
I can subtract it. Notice what happens if I subtract it. Now I got a bunch of negative signs. So let's go back and do something else that doesn't give us all those negative signs.
You could add the 4x.
There you go. I much prefer that. Anytime you can avoid negative signs, you should. There's no difference in having the x on the right or the left.
Okay.
Okay? So now what?
Divide by 4.
So now we have 25 equals x squared.
And then
Now,
take the square root of 25.
So x equals what?
5.
Actually plus or minus 5.
Oh.
Remember, whenever you're taking the square root of an equation, it's always plus or minus. Those should be the first words out of your mouth every single time.
Okay.
In this problem, they did say for which non-negative value of x. So we don't care about the minus 5. They're saying which positive value of x makes that undefined. Well, it's 5. And they only put the positive answer on there. Been a better question if they'd had a negative 5 on there also.
Yeah.
Because then you'd have had to make sure you go back and read, can't have a negative answer.
Yeah.
Even though negative 5 does satisfy that equation. How do we get the y-intercept of this?
How do we?
Oh, no, I'm sorry. That's not what it asks for. It asks for how do we get this in slope-intercept form.
Don't you move like everything over the equal sign?
Yep.
So y by itself?
Yep. Don't ask, tell me.
Oh, sorry.
No, I say that for a reason. I want you to start having confidence in your math skills. And if every question we go over you say, do you do this, it indicates a lack of certainty. And you're going to get better at this test, the more certain you get. I don't want that uncertainty there. There's no question that that's the way to solve this, is we solve this equation for y. And whatever we get, whatever it matches down here is our answer. So let's solve that for y. What do I need to do to solve it for y?
You add 3x and subtract 8.
There's your answer. Which one is that?
A. No, sorry. C.
Simple as that. The two squares have the same dimensions. The vertex of one square is at the exact center of the other square. What is the area of the shaded region? Well, I have to revise something that I've been saying for 5 years, and that is that every shaded region problem is a subtraction problem.
Okay.
This one is not. There's my gray square. This vertex of this other square sits dead at the center there. We need the area of that.
Okay.
Both squares.
So why don't you just do base times, or I don't know.
Base times height would give you the area of that whole square.
Oh.
So in a way, it really is a subtraction problem. It's the area of this whole square minus the area of that white part right there.
Okay.
What's the area of the whole square?
36.
What's the area of this little corner part?
9.
27. In other words, what we want is either the area of this whole square minus the little corner part, or we could just say, oh, that's 3/4 of the square. I can tell because that's a quarter. You knew that that was a quarter of the square. So the faster way to get it would really have been to take 3/4 times 36, and you get 27.
Okay.
Because we can see that the gray part is 3/4 of that square. Okay. The lengths of a triangle are 3, 4, 5. What kind of triangle is this?
I don't know the word, but I know it's like a...
It's a right triangle.
Yeah.
A right triangle is any triangle that has a right angle in it. And it turns out that a 3, 4, 5 right triangle is the smallest Pythagorean triangle you can get. There's no 2, 3, 4 or anything like that. There's 3, 4, 5, and then the next one is 5, 12, 13, where every side is a whole number. And that's a right triangle also. It behooves you to memorize both of those, just so you recognize them when you come across them.
Okay.
However, in this case, we don't care about the 5, 12, 13. They're saying that a similar triangle, that is, that has the same 3 angles, whatever this angle is here, that angle's there. Whatever this angle is here, that angle's there. Similar triangles have the same 3 angles. And similar triangles are completely proportional. Whatever the ratio of this side down here is to 3, it's the same ratio as x is to 4 or z is to 5. That's the thing about similar triangles, is the proportions are the same.
Okay.
Okay? What is the perimeter of that?
12. 12.
They want the short side. This, they're saying, has a perimeter of 36. And they want the short side, which is this side. You can see that the short side is the vertical side, the side that's 3 up here. Well, it's got to be the same short side down here. It's y. Well, what's y going to be?
Well, isn't that triangle 3 times bigger than the other one?
Yes, although that's not the correct way to say it.
Oh.
It's really not 3 times bigger in area. It's actually 9 times bigger in area. But its linear ratio is 3 times. In other words, the ratio of the perimeters is a linear measurement. It's not square meters, it's meters. Or inches, rather. It's not square inches. If I found the area of this triangle, it would be 1/2 3 times 4. Well, if I found the area of this triangle, I guarantee it's 9 times bigger than the area of this triangle. But the similarity ratio, the linear ratio, the ratio of one side to another is 3 to 1.
Okay.
Because the perimeters are the same. Perimeter is a linear measurement. So if the ratio of the perimeters is 3 to 1, that means the ratio of each side has to be 3 to 1. So what does this side have to be?
1? Or...
Look at the 2 triangles. Which one's the bigger one?
The 36 perimeter.
Oh, okay. So what's this side? Does it make sense if that was 1?
No.
What's it got to be?
9.
Yes. What's this one got to be?
12.
And what's this one got to be?
15.
Add those up, you get 36.
Okay.
Okay? The key thing is this ratio of linear. In other words, figuring out what is called the similarity ratio. It's really SR. I believe, have you been taught that it's called SR, the similarity? I've seen different words for it. To me, I call it the linear ratio as opposed to the area ratio. Notice the area of this bottom triangle is 54. The area of this top triangle is 6. This area is 9 times bigger than that. It's because when you go from a linear ratio to an area ratio, you have to square the ratio. So instead of the ratio being 3 to 1, it's going to go to 9 to 1. And that's always the case, regardless of you talking about triangles, circles, squares. If you go from a linear ratio, the area ratio is always going to be the square of the linear ratio. But we didn't even need to know that for this problem. We just needed to know that we were dealing in linear ratios. The perimeter ratio has to be the same as the similarity ratio. Well, this is a pretty easy problem. It's the first step.
Do we even need to know what A minus B is?
Sure. What's the first step? Let's divide both sides by 4. Gets rid of that 4, turns that into 10. Okay?
Okay.
Now, if I didn't know what AB was, or A minus B, I could not solve this. I have one quantity times another quantity equals 10. I can't solve that. If it was equal to 0, that's one thing. I could solve that. I'd set that equal to 0 or that equal to 0. But when it's equal to a number, you can't solve it. Unless they tell you what one of the quantities is. And they told us that one of the quantities was 20. So now what should I do? Substitute 20 for A minus B. So we get A plus B times 20 equals 10. Now what's the next step?
Subtract 20.
Divide by 20.
Oh, because you're timesing it.
You're timesing it. You're always wanting to do the inverse of what's being done. If I was adding 20, then you subtract 20. If I was subtracting 20, you would add 20. If I'm multiplying by 20, you got to divide by 20. If I'm dividing by 20, you got to multiply by 20. So what is A plus B equal to? Which answer?
On 24?
Uh-huh.
K?
Yeah. 1/2. After I divide by 20, the right side turns into 1/2. So I definitely needed this information.
Oh, okay.
In other words, I couldn't have solved it otherwise. I can't solve this equation that you're looking at right there, because A and B could be a whole bunch of different things. That actually has an infinite number of solutions. But when they give us this, now we know what a plus b is going to be. We still don't know what a or b is individually, but we don't care. Our goal is not to know what a is and to know what b is. Our goal is merely to know what the quantity a plus b is equal to.
Okay, that's where I got confused. I thought we had to solve a and b.
No, no. Always make sure you look at that final question. What is a plus b? Doesn't necessarily always mean you have to solve for a and b. You just need to solve for a plus b. Okay, next problem. Relatively high degree of difficulty. The profit as a function of x is where c is some constant that we don't know what it is yet. However, if 300 units were produced and made a profit of $1,900, can I solve for c?
Yes.
Okay, what's the next thing I want to write?
So wouldn't you equal it to 1,900?
Tell me that. Now what am I going to do after that?
And then 17x.
What's x? X is the number of units they sold, and they've told us that they sold 300 units to produce this $1,900 profit.
So 300
in place of x.
Minus 10 times 300 plus c.
And now solve for c. That's what they want, is what is c. So let's go through the arithmetic here. What's the first step?
Get rid of the parentheses.
Okay. Let's go from the inside out. Always work with parentheses from the inside out.
Okay.
Do this parentheses first. So we got 17 times 300 minus what?
3,000 plus c.
Okay, now let's get rid of the rest of the parentheses. What's that equal to?
5,100
minus
3,000 minus c.
Good. You have to apply that negative to the c. Okay. So we're almost there. Do that.
$2,100 minus
Now solve for c.
And then would you add 1,900 or would you subtract 21?
Well, in keeping with, I want positive coefficients in front of everything. If I subtracted 2,100 from both sides, I'm going to have a negative number on the left and I'm going to have a negative c on the right. So rather than do it that way, how about we move the c to the left and we move the 1,900 to the right?
Okay.
So what do we get? The c turns positive because I moved it to the other side.
You get 200.
That's the answer. Uh-oh, blurriness.
That's okay.
Well, I can always write them out. I can see them. Let's see. I think I can see them. Is that x to the 7a? I think it is. X to the 7a minus 2, the whole thing squared, cubed rather.
Yeah.
And that's equal to x to the 57th
Yeah.
And the question is, what is A? How do I do this right here?
Cube it.
How do you do that?
So you would do...
If I have 3 squared all cubed, what does that equal to? Not the number, but the next, that's equal to 3 to the 6th.
Yeah.
In other words, when I'm doing double exponentiation like this, you multiply those two things together. So what's the next step up here?
21a
Hold on, write the whole thing.
x to the power 21a minus 6.
Now, if that's equal to x to the 57th, what can I say next?
Add 6.
No. If I told you that 2 to the x was equal to 2 to the y, what could you say about x and y? They have to be equal.
Yeah.
You can't take a number to an exponent and have it be equal to the same number to a different exponent unless those exponents are equal. So the next step here, we have the same base, they're both x's, different exponents. So 21a minus 6 has to equal 57. I'm going to remove the x's from the equation. Now I can solve for a. Help me solve this for a.
You would add 6 to 57. And then divide 63, or divide 21.
Divide both sides by 21.
Yeah.
That's what we're doing. We're doing that. That leaves just a on the left, and a is equal to what?
3.
Okay. Answer G. Now, these are getting a little harder as we're getting a little deeper into it. This one really isn't that hard. If 3 times a number n is added to 9, the result is negative. Which of the following gives the possible values for n? Well, give me an equation or an inequality that I can write that reflects that first sentence.
So 3 times n plus 9 equals...
Not equals.
Oh. Oh. 0.
Right?
Yeah.
That's what negative means, less than 0. Not less than or equal to 0, but less than 0. 0 is neither positive nor negative. So when somebody says something's positive, it means it has to be greater than 0. If they say it's negative, it has to be less than 0. So now, which of the following gives possible values for n? Well, let's just solve this. This is easy to solve. How do I solve that?
Add 9 to 0.
Okay, what's being done to the 9 right now?
Oh, sorry, subtract 9 to 0.
Okay, that leaves 3n over there, minus 9 over there. Now what?
And then divide 3 both sides.
There's your answer. I did not have to switch the direction of the inequality sign because I was not dividing by a negative number. If this would have been a -3 and I had to divide by -3, then I got to turn the direction of this thing around.
Okay.
Whenever you multiply or divide an inequality by a negative number, you turn the direction of the inequality. At no point did I have to do that. I subtracted 9, that doesn't matter. It's only when you multiply or divide by a negative number that you have to switch the direction. Every step here was, that's fine, that's fine, that's fine. So n equals, or n has to be less than -3. Which answer?
D.
Okay. This question is almost identical to one we've already done. One end of a line segment in the xy coordinate plane is -5, 3. There's -5, 3, approximately. The midpoint of the segment is 9, -1. So there's the line segment. This is the midpoint. That means this thing must keep going, and somewhere over here is the end point. What are the coordinates on the other end point? Knowing that this distance is halfway, and knowing that is all you have to do is find the x-coordinate, we also know that this 9 is halfway between whatever my coordinate is and -5. So what did we do last time?
We added, or no, we subtracted.
We subtracted because we want to find this distance. What is that distance of the x-coordinate only?
-14.
Okay, it's 14. You don't have distances that are negative, ever.
Okay.
If I say, what's the side of a rectangle, you're not going to say -14. Distances are always scalar and they're always absolute. So we have 14 units between that. So what does my x-coordinate of this point way off my screen have to be?
And then once you add 14 to 9?
Yes, 23. That's my x-coordinate. Now, that actually gives me the answer. If you look at the answers, they only give you one that has 23 as the x-coordinate. Again, they're doing you a favor and only making you do half the work. But, as practice, let's do the other half the work. How far is it between the y-coordinates of this y-coordinate and this midpoint? It's -4. Okay. So how far is it to the next y-coordinate in that direction?
3.
That's going the other direction.
Oh.
In other words, I got to go down, right?
Yeah.
I got to have a bigger negative number.
What do you mean a bigger?
Well, here. I didn't draw this very good. I apologize. Let me fix it a little bit. All right. That's the midpoint. We know the line goes all the way to there. There's some other point here. We've already determined that the x-coordinate on that other point is 23. Why did we add 14 to 9? Because we were going from -5 to 9, which is to the right. So we know the x-coordinate has to be to the right of 9, which means it has to be 14 to the right of 9. Okay. Now let's look at the y-coordinates. The difference between the y-coordinates was 4, but it's going down. It's not going up. So on a number line, here's 3, here's -1, here's 0. So if I'm going down, that's the halfway point. I got to go down another 4 points to get to the final point. Well, what is this point right here if I got to go to the left 4 more units?
-8.
What's the difference between -8 and -1?
Oh, 7.
So it's not -8, is it?
So 9.
What's the difference between -9 and -1?
8.
Got to be 4. This distance has got to be 4 because this distance is 4.
Oh. Oh. Okay. -4.
-5.
No, -5.
There you go. So that's how we get -5. In other words, we went 4 units to get from 3 to -1. We have to go down another 4 units to get from -1 to -5. And that's the way you do those midpoint problems. The 2 problems we worked on today, the very first one was identical to this. It gave us a midpoint and it gave us the starting one. And it asked us to figure out the final one. So the fact that we had 2 identical questions on the same test, this is test 2 in both cases, means that you're going to find this problem on the test. You want to make sure you know how to do it.
Okay.
Okay? If they gave you the 2 endpoints and said, what's the midpoint, then all you need to do is find the halfway point between 23 and -5, and the halfway point between -5 and +3. And that would be the answer. That would be 9, -1. So regardless if they give you the 2 endpoints and ask for the midpoint, or give you 1 endpoint and the midpoint, you can figure out the other one. If you know 2 of the points, the key is knowing that this midpoint is halfway between the x's and halfway between the y's. That's the key for midpoint questions. So, let me give you a test. There's a line segment. Where's the midpoint?
Wouldn't it be 8,
No. If I put an 8 there, 8 is not halfway between 2 and 10. When you put an answer down, always in your head be checking it to see that it makes sense. Don't just put an answer down and hope that it's right. We know that this thing has to be halfway between 2 and 10. So I don't mind you guessing at answers, but after you guess, check to see if it's right. So what's it going to be? And I don't care if you're certain and you're wrong. That doesn't bother me a bit. What I want you to be is certain. I don't want you to go into this test. You're not going to be able to answer a question saying, is it 3? You're going to have to think that it's 3 and answer that.
Okay.
So what's halfway between 2 and 10? If you don't know how to figure it out, pick some numbers and just do trial and error. Is it 5? Huh?
No.
Is it 6?
No. Would it be 4?
It's 6.
Oh,
6 is 4 from 10 and 6 is 4 from 2. The way you technically get it is you take that plus that and divide by 2. In other words, you take 10 plus 2 divided by 2 gives you that midpoint. But I want you to be able to conceptually see it. In other words, you don't always have to use equations that you've memorized. In these cases with midpoints, you just need the halfway point, however you figure it out. Go ahead and guess. 8 is a fine first guess, but that doesn't work. So we got to change it. 7 would be another good guess, but that doesn't work either. When we get to 6, 6 is equidistant from 10 as it is from 2. What's the midpoint between 2 and 6? The y-coordinates.
3.
Check it.
Oh,
Does that work?
no.
Before you give an answer with certainty, I want you to check it in your head. Then give me the certain answer.
4.
There you go. 4 is 2 away from 2, and 4 is 2 away from 6. Now this was very easy because I used all positive numbers. Both problems we've looked at today had one negative number in each coordinate. So it becomes a little difficult when you use negative numbers. Let me change the problem up a little bit. I'll still use 10, 6 there. Now let's use -4 and -2. Now what's halfway between -4 and 10? Well, figure out the distance between -4 and 10 and divide it by 2. That would tell you what that halfway mark must be, but that's only going to tell you how far away it should be from 10 or how far away it should be from -4. But see if you can figure it out. What's the halfway point between -4 and 10? And it might be helpful to draw a number line. There's -4. There's 10. Where's halfway in between?
6.
Well, let's check 6.
Oh, wait, no.
How far is 6 from 10?
3.
No, it's 4.
Sorry, 4.
How far is 6 from -4?
10.
Okay, so we need a lower number. Remember how, well, I want you to be able to do this way. Because this is the way you would do it if nobody had ever taught you mathematics. If you'd never had a class in math, and I said, what's halfway between those two, you would start picking numbers and testing them. Well, 6 didn't work. 5 doesn't work. 4 doesn't work. 4 is 6 away from 10, but it's 8 away from -4. What about 3? 3 is how far away from 10?
7.
How far is it away from -4?
-7.
We're not really caring about signs here.
Okay, sorry.
Okay? We know that 3 is the midpoint between -4 and 10. So this coordinate on the x-coordinate has to be 3. Now what's the midpoint between 6 and -2? Again, pick some numbers and experiment. Make a guess.
2.
How far away is that from 6?
4.
How far away is it from -2?
4.
That's the midpoint. If it's equidistant, if it's the same distance to there, in other words, this distance is the same as that distance, that makes it the midpoint. And to use a number line might seem a little old-fashioned, but it always gets the answer, and you don't have to worry about subtracting or adding negative or positive numbers or anything. You just need to know what a number line, how it works.
Okay.
All right. Let's do one more problem here. Okay, this is a conic section problem. They're giving you the equation of a circle. In order to know what the radius of this is, we have to know the general formula for the equation of a circle. I gave it to you probably the first time I met you, but I don't know if we've done any since then. Maybe one or two, but this is something you just got to memorize. What's the general equation of a circle? The general formula.
I don't remember.
X minus h squared, where h is the x-coordinate of the center of the circle. Y minus k squared, where k is the y-coordinate of the center of the circle. And it's equal to the radius squared. There's the equation you need to memorize. And you need to know what h, k, and r mean. Because they're liable to ask you what's the center of that circle. If I said what's the center of that circle, what would it be?
Of x minus h?
No, I said h was the x-coordinate and k was the y-coordinate. So the center of the circle is h comma k, or in this case,
X.
3 comma 4. In other words, h is 3, k is 4. So if I had to graph this circle, I would start at 3 comma 4, and that's where I'm going to make the center of my circle. Is at that coordinate, 3 comma 4. Notice that it's x minus h and y minus k, and that's why it's positive 3 and positive 4 and not minus 3 or minus 4. What's the radius of my circle?
25.
R squared is equal to 25.
Oh. 5?
Yep. That's the answer to this question. So you're going to get a lot of varieties of this. You're going to get an equation like this where they say, what's the radius? And you're going to get an equation like this where they say, where's the center of this circle? So the key is to memorize this and to know what h, k, and r mean. And then no matter what they give you, you'll know how to answer it.
Okay.
Okay? All right, let's end with 29 there. I will talk to you next Sunday at 6 again.
Okay. Thank
All right? Okay, Lauren, have a good week.
you. You